When discussing the mathematics behind probability and chance, mathematicians use random variables, which are defined as variables whose values depend on the outcome. There are two main types of random variables: discrete random variables and continuous random variables. For the sake of this video,
you always hear about popular music and the charts and the top charts and stuff. But today I'm going to talk about things that you really don't pay attention about, like a number one spot.
I'm trying to film a math video here. Oh. When dealing with the mathematics behind probability and chance, mathematicians use random variables, which are defined as variables whose values depend on the outcome of a randomized event. There are two types of random variables: discrete random variables and continuous random variables. For this video, we'll be focusing on discrete random variables. A discrete random variable is a variable which has a finite number of values. Thus, the randomized event has a limited number of outcomes. A simple example of this is a dice roll, which is a random event with 6 outcomes. In the case of a fair die roll, each outcome has a sixth of a chance of occurring. Thus, we can assemble the following probability chart. Every discrete random variable has an expected value, which can be found by summing every value multiplied by the probability of the outcome being that value. This can be written using this formula. Using an example for the dice rolls, we can find that the expected value of a dice roll is 3.5. That means if I roll a bunch of dice, the expected value will be 3.5.
Hold on, that's actually like really helpful for me.
Why?
Because like I'm trying to figure out the expected like amount of weeks that a song usually stays number one on a chart. That's just expected value, no?
Oh yeah.
Okay. So if this is the data, I can use a pivot chart to lay out all the different values of weeks at number one, calculate all the probabilities, multiply each data point by the number of weeks, and sum them, and I get an expected value of 6.5 weeks. So there you have it, folks. A hit single usually stays at number one for 6 to 7 weeks. But songs like All Too Well by Taylor Swift doesn't feel like it would stay there, because that's a 10-minute song. It shouldn't stay that for that long.
But also, like Old Time Road, didn't that break a record for the number of weeks at number one?
How do I figure out how varied this data is?
That's fine. We can just use the expected value to find the variance, then root the variance to find the standard deviation.
What's a standard deviation?
Here. In layman's terms, standard deviation is a measure of how spread out a group of numbers is from the average, or mean. If the standard deviation is small, it means that most of the numbers in the group are close to the average, while if the standard deviation is large, it means that the numbers are more spread out from the average. That's pretty helpful. Okay, let me quickly do this with the dice and we can go into the songs. To find the variance of a discrete random variable, first sum the square of each value multiplied by the probability of the outcome being that value. Then subtract the square of the expected value. This can be written using this formula. By substituting the values for the dice roll, for example, we find the variance to be 35 over 12. The standard deviation then is hence the square root of 35 over 12, which is around 1.7.
Okay, so now I'm gonna use the formula.
Don't forget to square the x.
Right. We got this here. The sum of this. Okay. And then the variance. We take the sum minus expected value squared. Standard deviation is variance rooted. Okay, so apparently the standard deviation is 4.3. But what does that mean?
Well, assuming the data is normally distributed, that means that 68% of all songs on the charts stay there for a period of time within one standard deviation of the mean, which as you found is 6.5. That means that 68% of all songs stay on the charts between 2.2 weeks and 10.8 weeks.
How did you figure that all out? Just what?
But since the data is probably not normally distributed, I don't know.
We didn't get this far in planning.
We didn't get this far in planning.
The video's about done. Hi, Mr. King. How you doing? All right.